With our remaining time, let's do a couple improper integrals that are of a type that are actually probably worth memorizing. They come up a lot in applications, including some applications we'll look at on Friday. What's the improper integral from 0 to infinity of e to the negative kx dx? That is my cursive k. I always make my lowercase k's cursive because otherwise they look like uppercase k's. Does this converge or diverge? And if it converges, what does it converge to? Or what is the answer? K is a constant. Let's think about this intuitively, though, before we do it. K is negative, like negative 10 or something. Then negative K is positive. I am purposely putting a negative sign there. I want to. If K is negative, like negative 10, then negative K would be positive. If K is negative 10, negative K would be positive 10. E to the 10x grows really rapidly as x goes to infinity. There's no way the area under that graph is going to be finite. The improper integral is going to diverge for sure. The limit will not exist. If K is 0, then I'd have e to the 0, which is 1, whose graph is a horizontal line above the x-axis. Infinite area, if you let x go to infinity. That will diverge as well. It's only when K is positive, so that negative K is negative, that I have a chance of this integral converging. And you've learned in the past, ever since you learned about exponential functions, that exponential decays go to 0 pretty rapidly as x gets larger. Pretty rapidly, meaning probably the area under it is finite, even though the region itself goes out forever and ever. It's probably going to converge when K is positive. How do you confirm these things? Again, in this class, I want you to use a limit sign. In some later classes, you might be able to get away without one. But for full credit in this class on homework and exams, well, I do need to remember to tell the graders, I want to see the limit sign. It's a limit of proper integrals. The impropriety just is the fact that it's not an ordinary integral. It's a limit of ordinary integrals, if the limit exists. And at first, you just always carry the limit sign along. That's what we always do with limit signs. And you only evaluate the limit at the very end. The limit sign gets carried along for the ride. We need the fundamental theorem of calculus. I'm going to find an antiderivative of that in my head. Are you good at this yet? Can you do it in your head? That's what you should get. Integrating with respect to x, not k. And it is x that's going from 0 to b. I should probably emphasize that by writing x actually in here. X goes from 0 to b. Technically, this only works when k is not 0, because otherwise I'd be dividing by 0. The k equals 0 case can be treated separately. If k is 0, this is e to the 0, which is 1. Integrate 1, you get x. Evaluate x from 0 to b, you get b. And the limit as b goes to infinity of b is infinity, or I'll say it does not exist. It definitely diverges when k is 0. This one, it may not be so clear yet. Take it step by step. Be careful about negative signs. First, plug in b, keep the negative sign there. Then subtract what you get when you plug in 0, keep the negative sign there. E to the 0 is 1. Two negatives make a positive. This is the limit as b goes to infinity of positive 1 minus 1 over k e to the negative kb. Does that limit exist? Again, it depends on what k is. If k is negative, so that negative k is positive, then e to the negative kb gets larger and larger as b gets larger and larger. In fact, larger and larger without bound, larger very rapidly. This limit's not going to exist. Now, you might write minus infinity because of the minus sign there. I'm just going to write dne for does not exist. If k is negative. It only exists when k is positive. What does it equal if k is positive? You tell me. 1. Which makes me realize I made a mistake in the previous class because I think I wrote the answer was 1 over k. Did I make a mistake here? Oh, this should be a 1 over k here. Sorry. The answer is 1 over k. I thought that seemed wrong. This fact that the integral converges if k is positive, yes, I do want a negative sign there, and equals 1 over k in that case, is worth memorizing for the future. We'll see some applications of it on Friday. There are plenty of other situations where this integral comes up in applications. It's worth remembering that this improper integral converges when k is positive to 1 over k. You might argue, does it mean it really equals 1 over k? Does that really mean the area equals 1 over k? Well, there might be a valid argument to give. Probably a better way to say it is the area approaches 1 over k as the right endpoint gets bigger and bigger. That might be a better way to say it rather than saying the area of the region that goes on forever and ever is 1 over k. But it's kind of a distinction without a difference kind of thing. We effectively just say the area under the curve when x goes out forever and ever is 1 over k. And the last example for today is going to be to do the same thing with this integral. Integrate from 0 to infinity x times e to the negative kx, where once again k is a constant. And I'm just going to go ahead and assume k is positive here. If k is negative or 0, it definitely diverges. Let's assume k is positive. Right from the get-go. This one's a little trickier though, because the integral is a little harder to do. Can't do it so easily in your head. Looks like integration by parts. U is x, so that u prime is 1. V prime is e to the negative kx, so that v is negative 1 over k e to the negative kx. I just integrated in my head there to find v. Once again, just carry the limit sign along for the ride. When you use integration by parts, you do not change the limits of integration. That's only for substitution that you change them. There's not really a new variable. I mean, I've got a u and a v in there, but I'm not replacing the x. Ultimately, I'm still have functions involving x here. Whereas with substitution, w equals something, for example, I stay with the w. And I don't go back to x if I'm doing a definite integral. U times v, product from upper left to lower right there, is negative x over k e to the negative kx. X goes from 0 to b, minus the integral of v times u prime, As often happens here, two minus signs are going to cancel to give you a plus sign. And the 1 over k there can come out in front as a plus 1 over k integral of e to the negative kx from 0 to b. Just be careful. Plug in your limits of integration now. Here, you're going to get negative b over k, e to the negative k times b, minus negative 0 over k, e to the 0. There, the 0 is being multiplied, so this becomes just a 0 there. And just like with the previous problem, with this one, we're going to get another factor of minus 1 over k. So we get minus 1 over k squared e to the negative kx, x going from 0 to b. Very easy to make a mistake. Just be careful. Plug in b here, you'll get 1 over k squared, e to the negative kb. Subtract what you get when you plug in 0. E to the 0 is 1. So I get a minus 1 over k squared. Both this and this go to 0 as b goes to infinity. That's exponential decay. K is positive here, so that negative k is negative. It's going to 0 for sure as b gets larger and larger. This one's a little less clear, though you can use L'Hopital's rule to confirm it. I'm not doing that. You should be able to. So for the assignment due Friday, you may want to look up L'Hopital's rule or watch a video about it. For some examples, I might want you to confirm it. In fact, I think in the book's directions, they sometimes say use L'Hopital's rule. To confirm a limit like this is 0. In the end, there's your constant with two negative signs to make a plus sign. The answer is 1 over k squared. And that's actually worth memorizing as well. This improper integral comes up in a fair number of applications too. When k is positive, it converges and equals 1 over k squared. Okay. All right, we'll see you Friday.